This is June 2012 and we'll be looking at question 3. So for this question, the first thing you need to do is use your equation delta H equals mc delta T. M is the mass of water that you've used to raise the temperature of. So that's 200 grams. C is the specific heat capacity of water, and that's 4.2 joules per gram per Celsius. And delta T is the temperature difference, and you can see the heat produced raised the temperature of the water by 28.2 degrees C. Okay, so put that into your calculator and you should get 23,688 joules. And that is equal to 23.688 kilojoules, just dividing through by 1,000. Now, this is the enthalpy of combustion, so we know that it's going to be exothermic from that, but also you can see that we have raised the temperature of the water, and so that means heat has been given out, and so it is an exothermic reaction, and so we need to put in a negative sign here to show that it's exothermic. So the heat released from this reaction has produced 23.688 kilojoules. Now, that is the enthalpy change for the 0.47 grams of our hydrocarbon that we have used. So that is the exact energy change for 0.47 grams of hydrocarbon. Now, normally at this stage, what we would do is we would take the mass of our fuel, so in this case it's 0.47 grams. Usually we would take that and divide through by the RFM to get the number of moles of our hydrocarbon, and then we would work out the standard enthalpy of combustion by doing the standard enthalpy of combustion is the enthalpy change calculated here divided by the number of moles that we have. But in this case we are given the standard enthalpy of combustion, and so we need to use that and the value for delta H that we have calculated to work out the number of moles. So we're really just rearranging this equation to get the number of moles. So that means that the number of moles is going to equal delta H over the standard enthalpy of combustion. And if we put that into the equation, we can see that the units come out as what we want it to be. So the enthalpy change that we worked out for that specific mass of the hydrocarbon was 23.688 kilojoules. And then the standard enthalpy of combustion for that hydrocarbon is minus 2220 kilojoules per mole. So we can see that on the bottom half of the equation we've got moles to the minus 1, and these kilojoules are going to cancel out, and so we can see that our units work out as mole, because we've essentially got 1 over mole to the minus 1, which corresponds to mole to the power 1, which is just mole. Putting that into the calculator, we get that the number of moles of our hydrocarbon is 0.01067 moles. So I can then work out my RFM using the equation N equals mass over RFM, rearranged to give me RFM equals mass over N, which equals 0.47 grams over my 0.01067 moles, which corresponds to 44, which is answer B. So using the information, using the equation delta H equals mc delta T to work out the enthalpy change for this specific reaction, then using my standard enthalpy of combustion to work out the number of moles of hydrocarbon that I have, and then using that to work out my RFM. All of which you've done before, but just usually we would know what our hydrocarbon was, or what it might have been the likes of ethanol and alcohol, and we would have been able to work out the number of moles from that, and then use that to calculate the standard enthalpy of combustion. But in this case, they have given us the standard enthalpy of combustion, and so we use that to work out the number of moles.